Hello and welcome to Tuesday's edition of Cracking the Cryptic, where the heatwave here in the UK is in full force at the moment. It's about 34 degrees outside, which means my attic where I record these videos, it is sweltering. And I'm going to be doing battle in this video with a puzzle called Abstract Art by the great Marty Sears. This is actually a great follow-up to yesterday's puzzle, because yesterday we did the Penrose Steps by Fenners, which was a beautiful. I think I might still have it actually. Yeah, here we go. So this was Fenners' take on the sort of Escher picture, ascending and descending, which I'm sure lots of you are familiar with. It's a beautiful puzzle, this one, and we're following up with something, as I say, rather more abstract. And I believe more difficult. This has got 4 stars out of 5 for difficulty over on Logic Masters Germany. It's got some really cool rules. And I snipped some comments before I turned on the webcam. Silver Step says, oh yeah, this one's insane. Super glued a smile on my face. And Ratfinks said it's absolutely stunning, but did take 8.5 hours. That is a little bit concerning. Viking Prime says it's a great puzzle. Math Pesto says the interactions are brilliant. Fool on Hill solves beautifully. Peddling Pianist, another awesome example of your fantastic creativity. I think this is an older puzzle actually. You can see the last comment there is from 2023, so it's obviously been out for a while. I don't know why we missed it when it first came out, but apparently we did. And I'm looking forward very much to having a go at it, which we'll get to in a moment or two's time. Do I have any news for you before that? Yes, I certainly do. Last night, many of you joined us for our 10th visit to the Blueprints mansion, where we were trying to earn the inheritance that we felt we were due. I'm not going to reveal any spoilers about what happened. I will say we had fun. And we did enjoy it, and I definitely recommend you check out the video. And I hear your demands that we continue our journey. I can't speak to that at the moment, but I have heard you. Now the other thing I have been doing over on Patreon is I have been recording. I've recorded the first 2 hours of my attempt at this week's listener crossword, which is a puzzle called Listen by Eck, which I think is the pseudonym of Ed Hall. So I can't release that yet because the puzzle is still live, but I do intend to. And I had a message on Facebook from an old friend of mine, Steve Mulligan, saying please continue to record yourself doing that. So I am going to try and create a bit of a video series over on Patreon for anyone interested in cryptic crosswords. So that's going on. Also going on Patreon, of course, is the Labours of Rostam, which is our monthly competition. I forgot to be ready with the league table today, so I can't show where we're up to. But thousands of you already have been having a go at that and enjoying it, so that's wonderful to see. Do keep going. Plenty of time left. The competition closes on the 20th. Now, what else? Birthdays. I have 4, I think. We'll start with Brendan. Brendan, you've turned a secret age today. I wonder what that could be. And I know this. I think you're in Northern Illinois. Well, you usually are anyway. Your wife Karen wrote to us and said, could we give you a shout out? But I think the two of you, I think this might happen every year. You go on work trips to different places. So Brendan's going to Milwaukee and Karen's going to New York. And yeah, 2 ill-timed work trips. But I know that Karen has made you a rather splendid cake, and I have a picture of it. I think I do. There we go. It's not in the right place, but I do have a picture. Let's make it larger because it really deserves to be in full focus. That is a great-looking cake. It looks like the ratio of icing to cake is probably correct at around 1:1 as well. So Brendan, I hope you enjoy that. I know that your kids and dog Hunter were also wanted me to tell you how very proud they are of you, which is a rather nice thing. Now from Brendan turning a secret age, we will say a very happy birthday to Braden. Braden, your fiancée Melanie wrote to us and told us that you might like a shout out, and you work on our puzzles, or on the puzzles that we showcase anyway, every morning. So Braden, thank you for doing that. I hope you have a great day today. I hope your cake is just like Brendan's, frankly. And then we'll go to Gainesville, Florida, where Brittany, it's your birthday. And I know this because your husband Jesse wrote to us and told us that you love books, ghosts, dogs, and Sudoku. And the two of you have been watching since COVID, so thank you both for doing that. And Brittany, I hope you have an absolutely brilliant birthday today, obviously, with chocolate cake. And then we'll go to Spain finally, where actually Mariah, I hope I'm saying your name correctly. It looks like Mariah. Your partner Ernesto wrote to us, and it's not your birthday, but it's your Saint's Day, which I think is a bit akin to a birthday in Spain. And Mariah, I hope you have a great one today. I suspect you probably are hotter than the UK. If you are, I hope you're able to keep cool somehow, and I hope that there is cake to enjoy. That's all the news. So let's have a look at abstract art by the great Marty Sears. The rules are as follows. Divide the grid into 8 non-overlapping 2x4 regions, which can be placed either horizontally or vertically. So that means we could have a region that looks like that, or we could have a region that looks like that. Yeah, so I suppose the corners therefore are either like that or like that, and we're going to have to work it out. It must be determined which one of the digits 1 through 9 is missing from the grid. The other 8 digits should appear once in every row, column, and region. So there's a missing digit, and we're going to have to work out which one that is. And then we've got a whole series of constraints. So we've got RENBAN, pink. Digits along the pink line form a consecutive set which can appear in any order. So imagine this corner digit was a 1, then this thing would have to contain 1, 2, 3, 4. It would have to contain the digits 1, 2, 3, 4, 5, and 6. But the order is completely arbitrary. We could have all sorts of ordering going on, but it would have to be a consecutive sequence of non-repeating digits. Now, next, NABNER, yellow. No 2 digits on the yellow line may be consecutive or the same. So if this was a 2, you couldn't put 1 or 3 anywhere on the yellow line because they're obviously consecutive with 2, and you couldn't put 2 on it, which I guess oh, okay, that's quite interesting. I was about to say, you know, if you had that shape for a region and that shape for a region, you could have repeated a digit on the yellow line. I've actually just realised that that's not possible, but that's a bit solvy, so we'll get to that in a minute. Then we've got a region sum line, so this thing, darker blue, on the blue line, digits in each region have the same total. So we're going to have to split this thing up, and then let's say those are in one region, those are in one region, and those are in one region. Then these two, the sum of these two would be the same as the sum of these two would be the same as the sum of these two. That's how region sum lines work. Then we've got a German whisper, this one. Adjacent digits on a green line must have a difference of at least 5. So if this was a 1, this digit would have to be at least 6 in order to be sufficiently different from the digit 1. And so with this one. Parity, red. So we've got a parity line here. Digits on the red line must alternate between odd and even. So if this was odd, this would be even. If this was even, this would be odd. And then this would be even, etc. Palindrome, grey. That's that one. The string of digits on the grey line reads the same in either direction. So if this was 1, 2, 3, it would have to go 1, 2, 3, 2, 1. in order that if we read it from here, it reads 1, 2, 3, 2, 1, and if we read it from here, it reads 1, 2, 3, 2, 1. So it needs to read the same both ways round. It's like the word tenet, for example. And then, oh, hang on. No, we've still got 2 more rules. Same difference, turquoise. That must be this one. And those 2, presumably. Each pair of adjacent digits on a turquoise line has the same difference. This difference value can be different for different turquoise lines. So, if this square here was a 1, then whatever the difference is between this digit and this digit, let's say this was a 3. That could be 1, 3, and the difference there between these 2 is 2, therefore, so that would be a 5, I think. Yeah, and that would be a 3, and that would be a 5. And then that couldn't be a 3, so that would have to be a 7. So that line looks quite odd, but you get the idea of how it works. And then KROPKI, 2 digits connected by a black dot have a 2-to-1 ratio, so one is double the other. So if this digit was a 2, this digit has to be either 4, because 4 is double 2, or 1, because 2 is double 1. And they, I think, are all the rules. So all the constraints are basically standard. There's nothing unusual about those. The thing that's unusual is that we're going to have to put or orientate the regions, which is not normal except in deconstruction puzzles. But this is, after all, abstract art. Do have a go. The way to play is to click the link under the video as usual. But now, I get to play Let's Get Cracking. Now, I'll tell you something I just noticed. I noticed it when I was doing the example. I was trying to think about whether I could put this yellow thingy, the NABNER line, into 2 different regions, and I don't think I can. Because to do that, I'd have to sort of have, you know, I'd isolate a stripe of the grid, wouldn't I? Yeah, okay. So another way to see that is to think about this cell. Now this cell is either or part of a region that's orientated in that direction, or it's orientated in that direction, isn't it? So these 4 cells are always in the same region. And the same is going to be true of these cells. They're always in the same region, by exactly analogous logic, and these 2, and these 2. So all of those are sort of all in their own regions. And then either this is part of the left-hand region, in which case this is part of its own region, or this is part of its own region, and it could go down or it could go across, but either way you're sort of getting a 2-by-2 effect propagating through the grid. So alright, if we can view the grid as a checkerboard, but when I say a checkerboard I mean a 2-by-2 sequence of checkerboards, like this pattern, I think we can argue, let's just make those all lime, and all of these, I'll make these the black colour. I'm not sure that's going to be helpful, but maybe we should stare at it. But what I'm claiming, because of the logic that we just outlined, is that I don't actually. I think probably that's the only one it definitively matters for. Well, yeah, I mean it's oh maybe the region sum. We'll have a look at that in a moment. But for example, these 4 cells here, those ones, that is saying that these 3 digits are part of the same region from a region sum line perspective. So they're going to add up to at least 6. And that's only if 1, 2, and 3 are in the puzzle. I mean, okay, hang on. Maybe I'm starting this in totally the wrong way. Okay, let's... I can't see any of these other shapes as being terribly relevant, apart from, I mean, the yellow line not being able to have a repeated digit was in the rules anyway, so the fact that this is entirely within a region I don't think is here nor there. So let's abandon that plan. And let's go to the RENBAN here. Now that is 6 different digits of consecutiveness, isn't it? Now, if there is the digit 1 on that RENBAN, it will be the sequence 1, 2, 3, 4, 5, 6. If there is the digit 9 on that RENBAN, which is the most extreme alternative case, then it's going to have 9, 8, 7, 6, 5, 4. So we can see that 4, 5 and 6 simply have to be on that RENBAN, on this RENBAN here. And that means 4, 5 and 6 are definitely in the puzzle. So they are not the missing digits, or missing digit, which is now 1, 2, 3, 7, 8 or 9. Sorry, I'm just trying to think about what that might mean. I don't think this is terribly easy, actually. I mean, I shouldn't be surprised because it took somebody quite clever 8.5 hours to solve, but I know that has middly digits on it. I know that... I mean, the thing about NABNERs, a 5-cell NABNER would be lovely, because then that would have to be 1, 3, 5, 7, 9. But a 4-cell NABNER, I mean, if it had a 1 on it, it couldn't have a 2, so it then could have a 3. It could be 1, 3, 5, 7 as a minimum. So it has to have 1 digit from 7, 8, 9 on it. And 1 digit from 1, 2, 3 if we started with having a 9 on it instead. And that, I just don't think that's interesting. God, I don't know what to do here at all. I mean, is it the whisper then? Let's just deal quickly with the secrets of German whispers lines. German whispers lines firstly can't contain a 5, because to do so, if you put 5 here, what's this digit? It's got to be at least 5 different from 5. And if we go downwards, we get to 0 or negative numbers. They aren't Sudoku compliant. And if we go upwards, we get to 10 or higher, and those digits are double digits, and they aren't Sudoku compliant. So no 5s on a whisper. Now what that means is that each digit on a whisper either has the property of being below 5 or above 5. And the crucial thing to realise is that you can't have 2 of the same polarity vis-a-vis 5 next to each other. So if this was a 6, 7, 8 or 9, this couldn't also be from that set, because these couldn't be 5 apart at least, could they? 9 and 6 would be the furthest apart these could be, and that's only 3 apart. So this would have to be lower than 5, then this would have to be higher than 5, etc. So you get this sort of oscillation of polarity. So those digits are all one polarity, those digits are all the opposite polarity. Okay, so the black dot is opposite polarity digits. So one of these digits, because these aren't the same, this couldn't be a 2-4 pair or a 1-2 pair, for example, because that would imply they were both the same polarity vis-a-vis 5. These are different. So one of these is a 6, 7, 8 or 9 digit, but you can't put 7 or 9 on a black dot, because half of 7 and 9 are not integers. So one of these digits is a 6 or an 8, and the other is a 3 or a 4. Now, 4 and 6 are very... Well, yeah, there has to be one of 4 and 6 on it, doesn't there? Because it's not a 3-8 pair. They're not in a 1-to-2 ratio. So there is what I'm going to call a monogamous digit on this black dot. It's either got 4 or 6 on it. Now, if it's got 6 on it, what digits are going to be next to the 6? So let's make that a 6 just to show you what I mean. Well, this digit would have to be 1 and this digit would have to be 1, because 6 only has one legitimate partner that's 5 different from it from the Sudoku set. Now, if on the other hand this was 4, these would both have to be 9. So I don't know which way round it goes. Okay, hang on. So let's go back here. We know that 4, 5, and 6 are definitely in the puzzle. And I now know that 3 or 8 is in the puzzle. Or possibly both, but 1 certainly. 1 of 3 or 8. Okay, I still don't think I've understood this. So I'm now going to go through the lines one by one and try and work out which line, because I don't think that line's telling me anything. I don't think this line is, but I might revisit this one if I can't get anything else. This line I think has told me something. I don't. Do I think the region's some line? Oh. Yeah. No, that's 5 cells. Oh, sorry. I was thinking I could rule out. I can rule out that but that's a nonsense, isn't it? That I can rule out. That can't be a shape. I mean, it could in theory. It would fit with the parameters of the puzzle because it would leave a 2 by 2 there. But that is not a possible shape, because let's just show you that these 5 digits here would be a minimum of 1, 2, 3, 4, and 5, summing to 15, which would have to be what this cell contained. That won't work. Can't write 15 into the puzzle. So this 2 by 2, which I know was in the checkerboarding, it doesn't extend to the right. So that doesn't really show up, but that is a border of the puzzle. And this 2 by 2, the thing is, this 2 by 2 can now still go up, left, or down. And this 2 by 2 just can't go left. I don't know, this is definitely not easy. So, okay, so we got a bit more info from this line. I think these are disambiguating, so I'm not going to look at those. That one, I don't know. I suspect does nothing, which leaves this one as having to do quite a lot of hard work. Now, the parity line can't do anything, can it? I mean, what we're being told there is that those 3 digits have the same parity, but we don't know whether it's odd or even. And these 2 digits have the same parity, so that's useless. So the palindrome element of it is telling us that those 2 are the same and these 2 are the same. So those 2 digits, let's label those A. We'll give it big A. So these are A, those are B. A and B have to be definitely different because they're in the same column and row. Yes. Okay, I've got one thing. Now, this 2 by 2 in the corner, could it go left? No, because I'd have 2 B's in that same region. So that doesn't work. So there is one region that's going here. Oh, hang on, I know what I want to do. I'm going to do this because I enjoy doing this. There we go. That makes me feel like I've made progress. So I've now got my first region identified. And this, you see, it's quite interesting. Oh. So okay. This digit is not a 5. There I've said it. If you can see why that is, well done. I mean, it's such a nonsensical deduction. But the way I'm getting that is thinking about this 2 by 2. Now this 2 by 2 either extends upwards, in which case you've got this region. And I know 5 is a digit in the puzzle, and we said 5 can't go on a whisper. So if this does go vertical, 5 is in this domino. But if this goes horizontal, and that's the region, again we couldn't put 5 on the whisper, so there would be a 5 in one of those 2, And so whether the 5s are in here or in here, they're looking at this cell, which is now only able to be those things. Don't worry, I'm not leaving that in. It's just something I've just noticed when I was thinking about which way this went. So A is in one of those cells, so it might have to be on this turquoise thingy. Well, no, but it doesn't. It doesn't have to be. The turquoise thingy is terrifying to me. I don't find the logic on same difference lines very intuitive, I have to say. I mean, yeah, I think that could be... Maybe you can't have an enormous difference on this. If you had a... Yeah, I mean, if for example, if this was 1, and we said, okay, let's have a difference of 4, then this would have to look like that. But then this has to have a 4 difference, and that would be a 5 again, and that's going to repeat. So that wouldn't work, but... I mean, but the thing is, this doesn't have to be a low digit. If you have a difference of 3, 3, 5, 5, 7, 7, 9 is fine, I think. So that's a difference of 2 working. 1, 4, 7, 4, 7. Yeah, that's more difficult. A difference of 3 might be tricky, although I'm not certain it doesn't work. If this was a higher, no, maybe it okay, no, maybe it doesn't work, because a difference of 3 is, I think, always going to cause a problem on the opposite sides. Because I mean, even if that was 4, yeah, or middly, the point is you could. Oh, well, maybe you could do that. No, you can't, because then this is the problem. This problem just shifts around the ring. Yeah, I'm not sure you can have 3. You can presumably have 1 though, can't you? 1, 2, 3, 4, or 2. No, you can't have 2, because this would be a 1, and then I'd run into a problem there. So you could have 4, 5, 4, 3, 2. So I found, okay, I found at least two differences that work around there. So again, how is that restricting anything? Ah. Okay, isn't it true that opposite digits on this ringy thing have to have the same parity? I think that must be true, because you're always taking an even number of differences. To get from here to here, for example, you're either going up twice, or you're going up and down, or you're going down and up, if you see what I mean. So either you've got the same digit, or you've got a digit that's 2 differences different, which is going to retain the parity of whatever this is. And then that logic must apply here. So those digits are of the same parity. These digits are of the same parity. Now, so if... The thing is that even that doesn't seem to do anything, because even... I don't know the digits in the puzzle, and there are 4 even digits and there are 5 odd digits, so I could even miss out an odd digit. The only thing that might be critical is if I could prove an even digit. No. if I knew an even digit was not in the puzzle, then I would know that these 4 digits had to... Oh, no, I still don't know anything. They could all 4 be odd, or 2 of them could be odd and 2 of them could be even. I still don't know anything. Oh dear, oh dear. And I don't even know that the corner digits have a different parity to the digits in the middle of the side, do I? Because obviously, if this has an even difference, then the whole ring has the same parity. I don't know. I'm a bit stuck. It's not this, is it? It can't be that. I don't think it can be this. I'm just going to think about that for a second. Oh yeah, okay. Oh no. Oh, or is it this? Because actually, there's 2 lines here. They're the same digit. Oh, Marty, you're so... He's so annoying. Okay, there is a deduction there, isn't there? Because, well, just the fact that we have to fill these 2 digits with something, whatever I fill them with, either... Well, if these are different to each other, then this digit has to sort of be the average, if you like, doesn't it? I mean, if this was 4 and this was 8, the difference between these, what digit do we put in here that gives the same difference there and the same difference there? That has to be 6, but so does that. Now, if on the other hand, these are the same digits, make that 3, then whatever I put in here could be, these could be different, but these are the same. So the point is that on one... Oh, this is really weird. Marty is he's just got such an unusual brain. It's very hard to get to grips with it. He's very gifted though. So what we've just proved is that either those are the same or these are the same. But the point about that is, how could this be a region? It can't be, because either those are the same or they're the same. So the region, so the region that involves the top, this 2 by 2 goes downwards and includes it includes the entire RENBAN, but that's not very useful, is it? So if that goes across, that would have to go down. That's interesting. If that's a region of the puzzle, basically the whole puzzle is going to get almost specified, I think. In fact, I bet that would specify the entire puzzle. The whole thing would fall into place, because that would be a region, 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 and that would be a region. Just if we could prove that. If, on the other hand, that's a region, that doesn't specify the whole thing at all. How weird. So proving that is a region would be really rather lovely. Oh, I don't know. How am I meant to do this? I'm really... Oh, okay. Is it maybe you can't have... Oh, I see. Okay. Oh, that's a terrible colour. Terrible choice of colour. Right, hang on. How does that work? So if I split this long turquoise line and it has a long sort of staple shape on it. I'm just trying to think about how that could work, because to me that looks like it's either, because all of those digits are different, if the difference is 2, that would have to be 13579, wouldn't it? And that, I can't see how that works. And if it was 1 2 3 4 5, the problem is you have to come back to your own value. Yeah, this doesn't work. Ah, okay. So maybe this was the one I was meant to start with. I hadn't appreciated that there is a problem with this, having to go back to the beginning again. Right. This shape is certainly impossible, so I think I'm going to get another region that's going down there. Let me explain. If this was a region, we have to decide what possible difference we could have that can survive these 5 digits being different. And hopefully it's very clear that these have to be extreme within that sequence, these 2 cells here. Because if we try and put this as, or this as the lowest digit on the sequence, for example, obviously because there's the same difference that way and that way, these would be the same digit. That cannot be right. So these are extreme within the sequence, and it's like a thermometer. It's either going to ascend from here to here continually, or ascend from here to here continually. Now, if the difference is 3, therefore, and we start as low as we can, we go 1 4 7 broken. That would be a 10. If we have a difference of 2, we could do that, 1 3 5 7 9. If we have a difference of 1 1 2 3 4 5, those things work. But the problem comes when you have to come back to yourself. So let's look at it. Let's do differences of 2 first. 1 3 5 7 9. What is this digit? Because we've got to get back to 1 in steps of 2, so we've got to go 7 5 3. It can't possibly work. It doesn't work. And it's the same if we use a difference of 1. Whoops. I've got to use differences of 1 to get back to 1, so I just have to reverse the sequence. It effectively becomes palindromic. So this is wrong. That's a long-winded way of explaining, but that is definitely wrong. I think we're going to do better though with that, because surely I can use symmetry to help me now. Having proved this is a region, this can't be a region, because that's going to create a great big stapley thing as well. So now that has to be a region. Oh, Bobbins McBobbins face. Now we're not going to know, are we? Because it could be that way or that way by the looks of things. Okay, but this line, I'm now thinking, is more constrained than I used to think it was. In fact, something I might just have realised, which I should have realised earlier, that the lowest digit on this sequence can never be in one of those positions, can it? Well, and same for the highest digit. Because if the lowest digit was in any of those 4 positions, it doesn't matter what the difference is. So let's just call that the minimum digit. Let's make it M for minimum, and maximum for that matter. It's the same point. Well, let's say the difference is D. Then, if this is the maximum digit, this would be M minus D, and this would be M minus D, and they would clash by Sudoku, so that doesn't work. So that means that these 4 cells here contain both the biggest and the smallest digit on this line. Yeah, this is beautiful. This is beautiful. Right, that can't be a maximum or minimum digit, because using our checkerboard principle, those 4 digits are in the same box. So imagine that was a maximum digit. Both of these would be m minus d. That's impossible. They're in the same box of the Sudoku. They're going to break Sudoku. So that is not a maximum, or a minimum. So these are the maximum and minimum digits. So let's just give those colours. So I feel like that one can't be correct. If let's say that was a 1, obviously therefore specifying it as the minimum, then one of these is the maximum. And even if they were both the maximum, how can that possibly be right? Let's make that 3 and that 5. So the difference has been established as 2, so these are the same. But what do we put here now? These are all in the same category, aren't they? And we know that we can't go higher in here because we've established that the maximum and the minimums live in these cells. So this would have to be 3, and it will clash. Yeah, it doesn't work. And the same, I mean, it's just symmetrical. If we made this a 9 instead, it's going to fail for exactly the same reason. So this one is not a max minimum digit. These are these are the biggest and smallest cells on this ringy thing. This is bizarre. It's bizarre. The most bizarre thing about it is that there's many things that are bizarre. There's many things that are bizarre. It's really bizarre that just happens, isn't it? That a same difference line that's a square, you can establish where the maximum and minimum digits are on it in a puzzle of this nature because of the shape of the regions. See, for Marty will be like, yeah, of course you can. Well, it's just this. But for Simon, it's like, no, that is not obvious at all. At all. So now, so now this is like a thermometer, isn't it? That's going to go, I mean, let's say this was low. It's going to go, if this is low and the difference is D, then this is going to be L plus D, L plus 2D, L plus 3D, L plus 4D, and this will be the maximum. So then we've got to unwind all those D's. So this will be L plus 3D, L plus 2D, L plus D, back to L again. So what that tells you, this is bizarre, is that those 2 digits are the same, these 2 digits are the same, and those 2 digits are the same on this difference ringy thing. So, okay, so what we have to do, right, we're going to change our colouring. We're going to say, I don't know which way round this goes, so I'm not going to say that this is low. I know blue is normally my low colour, but I'm going to say that that's blue and that's orange, and I don't know which way round this goes. Now, but I've just proved, I think, that those are the same, and, oh, no, the very digit we shouldn't use. Oh, my door's about to slam, hopefully it's okay. Right, so these are the same, these are the same, and these are the same. Marty is a genius. He's a genius, right? So now that's not a region. Because how could this be? Well, it's a good colour to make it, actually. If I make it black, how do I put this digit in it? We do have to in some way obey the rules of Sudoku in this puzzle. And it couldn't have this repeated digit in it if that was a region. So So that means that's great. That's great, because that means that I have to draw that boundary in, and I am going to get the grid fully specified now, because it just fills in with all the gaps from the work we've done before. So now at least we can, now we're at least doing a Sudoku we can understand. Now, now what does that mean? Oh, so my region sum line is the most awful thing possible. It's 3 digits there adding up to 3 digits there, and I still haven't got a clue what the missing digit is. All I know is it's not 4, 5, 6 and 1 of 3 and 8, or possibly, but 3 and 8 could be in it, in the puzzle. Oh, where's 5? 5 in this box. We can go back to the earlier logic we were looking at. That is the world's most underwhelming deduction, isn't it? 5 does have to appear, though, in every box. And it can never appear on a green line. So, but I think it can appear on this line. It might even have to appear on that line. Yeah, this line has got 5 different digits on it. Now, if the common difference on this line is 1, then it's either, it could be 1, 2, 3, 4, 5, or it could start with 9 and be 9, 8, 7, 6, 5, but it's always got 5 on it, is what that's telling us. If the common difference on this line is 2, then because this is operating a bit like a thermo, it's going to be 1, 3, 5, 7, 9, and it's still got 5 on it. So this line, but we don't know how many 5s it's got on it. It might only have 1. If it's a common difference of 1 line, one of those is a 5. But if it's a common difference of 2 line, then both of those are a 5. I don't know, and I do know there's a 5 on the RENBAN. This is it's really difficult, actually. It's very difficult because Marty is so clever that the thing he's buried in here might be really hard to see. It might genuinely be really hard to see. Well, okay, can we use the law of leftovers? Because I know that there's a no, okay, a bit. If we look at the first 2 rows of the puzzle, we know that they have to have 2 of all of the 8 digits that we are going to include in the puzzle, don't we? So, in other words, we know 5 is a digit in the puzzle. I know that there's got to be a 5 in this complete region. I know there's a 5 in this domino. So the 2 5s in the first 2 rows are in those cells. So they're not in those cells. So the 5 in box 1 is in one of those cells, and I know it's on the RENBAN. So there's a 5 in one of those. I've just seen it. I've just seen what we've got to do. I'm just checking. Let me just think this. I think it's right. It's just genius. He's a genius. It's just beautiful. Right, it's this point, but it's for this yellow thing. Right. So what I just did was I was trying to think about 5s. And I realised there was this sort of law of leftovers point. Those 4 digits are going to be the same as those 4 digits. But that's much more relevant if we look down this into this area of the grid, isn't it? Let's just highlight, let's highlight those cells. Now, these magenta or indigo cells are definitely 2 complete sets of the digits that are used in this puzzle. And that's a complete set. So these ones I'm sort of flashing on and off there, that is a complete set of digits that are used in this puzzle. That's one of each of the 8 digits. Unfortunately, we don't know what those 8 digits are yet. But very crucially, as regards this region then, which is one complete set of the digits in the puzzle, that must be those 4 and these 4 which live up here. And that's really important because those 4 contain no consecutive digits. So these 4, I mean, I suppose one way of doing it would be to draw that line. That's actually quite a nice way of doing it. That's true. The digits on this are repeated down there. So this is a valid yellow NABNER line. And what do we know about NABNER lines? There are no consecutive digits on it. So how could the common difference on this turquoise line be 1? It cannot be. It cannot be. I mean, it's the most beautiful idea. I mean, how can it be, Marty, that what Marty's done is embed this NABNER actually affects this common difference line? It's ridiculous. And now, so now, well, we know that this must be a 1, 3, 5, 7, 9 line. It's definitely got to have. It's definitely got to have 5 different digits on it. These are the maximum, these are the minimum. Those are all different. Yeah, that logic is sound. So I don't know what the order is still, but I know they're 1 and 9. I do know those are both 5. So is that my first digit in the puzzle? That's taken me nearly an hour. So this is either going 1, 3, 5, 7, 9, 7, 5, 3, 1, or it's going 9, 7, 5, 3, 1, 3, 5, 7, 9. So all of the odd digits are in the puzzle, and 2 of the even digits are known to be in the puzzle, which are 4 and 6. And we know that 4 and 6 are in it because of this RENBAN line. So the missing digit is now either 2 or 8. So if I can prove that's 4, 8, then 2 is missing from the puzzle. Oh, that's a 5 by Sudoku. Didn't see that, but I just have. Let's make that purple. Whoops. Now. Yeah, okay. Purple is a 5. I can't put 5 on a green line. So in this row, where's 5? Can't go in those cells. That's 5. That's on the blue line. 5. No, 5 can absolutely go here, can't it? This line here. This line here is probably made up of odd digits, frankly. So I suspect it's going to have a 5 on it. Oh no, that's lovely. It's lovely. Right, where's 5 in this row, row 6? It's not here by Sudoku, here by Sudoku, there by Sudoku. It can't be A, because that's A. If remember from the palindrome, the 2 A digits are the same. So if I make that 5, that's a 5, and it's going to clash. So this is 5. This is 5. Let's get the 5 out of there. And I've got so many 5s, I must be able to get all the 5s. I have Famous last word. Yes, we can use the same trick. Where's 5 in this box? It's not in those cells. It's not either of these. Now, if it was B, it would reflect here and clash. So it's not B. So I think it's... Right, this is great. So now it's there, which we've learnt from our earlier logic means that 5 is on this thingy here, and it has to go there. And that's all the 5s placed in the puzzle. And therefore, I really hope that's going to do something. Well, that digit can't be 4 or 6 because it would be consecutive with 5. And I know 4 and 6 are in the puzzle, so there's a 4 and a 6 in that sequence, which by the law of leftovers means there's a 4 and a 6 in that sequence. Maybe I've got to get rid of my A's and B's now. I think I will. I think I'm going to try and remember. Actually, I know what I'll do. I'll put A in the middle and B in the middle there. That's going to be helpful. And there's definitely 4 and 6 here, and 4 and 6 here. And this black dot is either 3, 6 or 4, 8. And whatever it is... Yeah, the thing is, whether it's got 6 or 4 on it, it's always going to have an extreme digit, 1 or 9. But we actually know 1 and 9 are in the puzzle, so that's not a good outcome. Oh, see, this doesn't work either. If the parity on the red line, if those two are odd, they have to be a 1-9 pair. Because 3, 7 and 5 have gone in the row, but they can be a 1-9 pair. And if they're even, that would be even, but that looks quite good as well, doesn't it? Oh, I'm sorry. I don't know. I've got stuck again. What do we think? This RENBAN can't have both we know both extreme digits are in this puzzle. We know there's a 1 in it, we know there's a 9 in it. They can't both go on a 6-cell RENBAN. So there is either a 1 or a 9 or both in those cells. Don't know what that does. Not sure. I know this is... One of these is extreme. So let's say that was extreme. Both of those will be... So when I say extreme, 4 or 6, that's going to cause that to be either double 1 or double 9. Yes. Oh, okay. This digit is 4 or 6. Because I can put one of 4 and 6 on the black dot. But I know both of 4 and 6 are in the puzzle. And 4, whether it's 4 or 6, they can't go in any of those cells. Because they have 2 neighbours within the box. So imagine that was 4. I mean, that doesn't work for many reasons, but both of those would have to be 9. If that's a 4, both of those have to be 9. If this is a 4, both of those have to be 9. And if that's a 4, both of those have to be 9. You can't do it. So that is a 4 or a 6. Now that digit in this box is going to go in one of those 2, and it's going to go in one of those 3, but it has to be on the line, so it's going to go in one of those 2. So that digit... That digit, let's give that a colour, is in one of those 2 cells. I mean, I don't know. Does that help me? I don't think it does. Goodness me, I am stuck. Right, okay, come on, Simon. There must be. I mean, I know this digit is odd. That's definitely true. So it can't be a black or an orange digit. So this digit is either blue or green. And black and orange have to be on this. I feel like I'm being very, very dumb here, actually. I don't know what to do. It's very clever. It's very clever, this. And I don't understand it. It can't be. I was about to say it can't be the whisper. I'm not sure it can't be the whisper. I mean, maybe it can be the whisper, but I don't understand how it's resolved, which way round it goes. It can't. Can it be the... I don't know. I was wondering whether it could be the blue line, the region sum line. I don't like the look of that. I don't... What? How am I meant to think about this? Is it... Have I missed a really obvious point? I now think I might have missed something very obvious. And I apologise to you all on behalf of my brain. But my brain is really being incredibly recalcitrant here. I'm trying to think about whether I can use the law of leftovers somehow to help me. Or perhaps the fact I've got these 3 7 pairs along the weird line. There is no way I know the orientation of this, is there? That would be quite helpful. I know those 2 digits are the same. But I literally... I suppose if they're odd, they have to be the blue digit, don't they? Because they couldn't be... This one can't be orange or black, and this one can't be green. So if this is odd, these are blue. And then that would be orange. Now, is that a problem? I don't know, is the honest answer. I don't know. And I wish I knew on this line which way round the... You know, which one of these was 4 or 6. That does feel like it's important, doesn't it? I mean, if this was... I don't know, what I was about to say isn't true. I was going to say if it was 3 6, then what would you attach the 3 to? It would have to be 8 9, but it doesn't, because 3 could attach to 9 twice. So it wouldn't necessarily mean that there is an 8 in the puzzle either way, because I mean this could be 4 8 putting 8 in the puzzle, and if it's 3 6 it looks like there could be an 8, but it wouldn't be necessarily have to be an 8. This one, these are the same as these. I definitely know there's a black digit there. I definitely know there's an orange digit there. Oh. No, that's what I was about to say is nonsense. It's just such nonsense. Don't talk nonsense. I was going to try and relate this having black and orange in to this box, but you can't do that at all. It's complete and utter nonsense. I mean, green and blue. Blue is a really interesting digit because it's either on the RENBAN, which would force the RENBAN to be extreme, or it's exactly there, which may or may not be fine. Goodness me. Or maybe I don't know where to look. It's not to do with the fact I've got 4s and 6s down here, is it? I mean, obviously I can't put both here because then the parity line won't work. And I know that that's... What am I missing here? How are we meant to do this? Three. I wonder if it's... I was about to say, I bet it's Sudoku. I don't actually... I think maybe I've got to get rid of the colouring round there, do I? Let's get rid of that. I don't think it's helping me. I think I've got to focus more on digits, is my feeling. But that's all very well. It's all very well to say that. But how do we do it? And is there... I feel like there might be something I'm meant to be able to extract from this line. But goodness only knows what it is. If that's a 4, that's an 8. This would be double 9. Is that a problem? And if so, where am I even looking for the problem that would arise from that? It's not... Oh, I'd love to know what the digit is. I know it's 2 or 8, don't I? That's... So if 2 is in the puzzle, 2 would have to be in one of those cells. Oh, actually 7 is in the puzzle, isn't it? Oh, I haven't had this thought. This is a good thought. 7 is a definite digit in the puzzle. And I haven't put it in this box. And I can't put it in either of those cells because 7 only partners up on whispers with 1s and 2s. So 7 is in one of those cells. Where it will... whichever one it's in is next to a 1 or a 2. So these are from 7, 1 and 2. And if it was 2, well, it is 2. Oh, that's how I've done it. That is sick. It's simple once you see it. Okay, why am I saying that? Well, because I don't know whether the 7 goes here or here. The point is it must have both its valid German whispers neighbours somewhere in this box. And 7 can only neighbour 1 and 2. So that tells me 2 is in the puzzle. And now I definitely know there are 8 digits in the puzzle, which are 2, 4, 6, and all the odds. So 8 is not in the puzzle, and now I know what this is. This has got to be 3, 6. Now, well, yeah, this now can't have the 1 on it, because whichever one of these is 6 has to have a 1 next to it. So this is not. This is 2, 7 now. And there is a 1 in one of those cells. Oh, hang on. If that's 3, 6, that's 4. 4 is in one of these two. So these digits are 1, 9 now, and that's forced by Sudoku. And therefore, what? Well, okay, if this digit is a 6, this is a 1. If this digit is a 3, this can't be 8, so it's 9. So this digit is 1 or 9, and that digit is analogous, and that is 1 or 9. And these are different because they're not of the same polarity. So this cell, for example, now can't be 1 or 9 because it sees both flavours. In fact, we can colour them. That's orange because it's not blue, so that's blue by colouring, which is the same colouring as this one. So that's blue. This is orange. Orange is... we already knew orange was on this line. Sorry, I thought maybe I could do some more cleverness. Well, hang on. Yeah, this is interesting. Let's have a look down here now. Because I haven't put... What do we do? So there's no 8 in the puzzle. So these digits are from 2, 4 and 7. And they're on a palindrome. So these digits are from 2, 4 and 7. And that, well, oh gosh, there's a 7 looking at that digit, and that's therefore even. This is even by palindrome, but this is on the parity line. So now that is even, which means it's 2, 4 or 6, because 8 isn't in the puzzle. And these are both, so this is not 4 or 6 now, because both of these are odd. And these, oh, they're different. That's weird. Yeah, these have to be from 1 or 9 because this sees 3, 7, 5. Actually, is that the same for this one? No, actually, I don't trust that one. I'm not sure about that one. I was thinking of palindrome logic, but this one certainly is 1 or 9, and we can see it's now orange. And now I can place orange in this box by Sudoku. It goes there. And therefore, what does that mean? I'm not sure. This is odd. But I'm not so sure I know what it is. This is 2, 4 or 6. And there's probably lots of stuff we can do if I can think of it. Oh dear. Well, 6. I've got 6 as being over here. Is that true? Yeah, there's got to be a 6. There's got to be 2 6s in this column, and there's a 6 in that box, and there's not a 6 on that line. So there's a 6 down here, and it can't go on the parity line. So that is a 6. That's just forced. And you think you get that, and you think, oh well, that's really going to be helpful. No, it's not. That's the only 6 I've got in the puzzle. I don't know what to do with it. Okay, alright, so here's a different idea then. Where's 4 in this column? Now it definitely isn't on this NABNER. It might be here. It might be there, I'm not sure. But the question I want to ask is, really, can it be in either of these cells? And I think the answer is no. Because if it was here, this digit would have to be a 1 or... Well, if that's a 4, this would have to be 9. But the point is it sees a 1-9 pair. And if it's here, both of these have to be 9. And that's obviously wrong. So 4 in this column is there. And that's on the palindrome. So now this digit is a 2. And that digit's a 2. And that digit is not a 2. And this digit is a 7. Oh, it still doesn't do it. It must. Oh, well, it gets me a 7 there, does it? By Sudoku. So that digit is blue 1 or 9, which is a bit of a surprise. So this is blue, it's those digits, and that's not orange. Or blue. So that one is the 3 or the 7. These are not the black digit anymore. This is a 1-9 pair. And surely we can do this column now. We've got to put 4, 6 and 3 into it. Whoops. 4, 6 and 3. There's definitely a 3 on this blue line now. And in this column, well, where's 2 in this column? And the answer is I don't know, but it's definitely in one of those cells, isn't it? And that's going to have to go. If 2 is in this domino, the other digit in this domino is a high digit, because that's how German whispers work. But it's not a 9 that's partnering it, because 9's gone. And it's not an 8, because 8 isn't in the puzzle. So that's a 2-7 pair. And therefore this digit is a 3, which is the same as that digit. And that, right, that's done it. That's got me the polarity of this thingy. So oranges, oops, those oranges are all 1. And now I've got the German whispers line polarity. So that's 7, that's 2. That's blue is 9. Oh, this is 7. This is 2. This is 3. This is 6. Now that is 3 by Sudoku. Oh, this is genuinely exciting now. I think we might have broken into this. 3, 6, 9 into those squares. That's a naked single. This is and that's 3 in the corner. That's 3 in the spotlight, losing its religion. These squares are a 1-6 pair. So this is 9. These are 7. So our line here was ascending from this. Yeah, so I got the colours the wrong way round, but never mind. We will forgive ourselves that. These digits here are 2, 4. No, they're not 2, 4 and 6. They're 2. Oh, there's one of them's a 3. And that's a 4, and that's a 2. So that's a 6, and that's a 4. We're going to have to look at this line. That's going to be very useful for those digits in a moment. And this row needs a 9 in it. So this is going to be a good check, actually, to see if we're on the right track, isn't it? Because the digits that we've not put in here are all the even digits, 2, 4 and 6, and they add up to 12, and so do 3, 4 and 5. So the region sum line works, and that does suggest that we haven't made a complete Horlicks of the puzzle. That's a 4 now by Sudoku, which was our magenta digit originally. These squares are... Now I've put 2 6s in this row. That's not a good thing at all. My Sudoku has not gone very... My Sudoku is absolutely broken there, hasn't it? No, it was going really well. 1, 2, 3, 4. It's possible, it's very possible that I've messed it up. Well, I don't know. Where would I have messed that up? What did I get wrong in all my thinking? Oh, this is bad. I've got 2 4s in this row as well, so something's gone really awry. Where do we think that the problem arose? The bottom row needed 1 and 6, and then I put... So this box, if I filled it correctly, it's got 1, 2, 3, 4, 5, 6, 7, 9. That looks plausible. This 4 gives you this digit, which is 6. That gives you this digit, which is 4. I should have seen that that gave me this digit as 4. So have I... This row definitely doesn't have 9 in it though, does it? So that's got to be 9. And now there is definitely nowhere for 4 in this box. Oh, that's so distressing. Okay, let's check. Did I do the whisper correctly? 9. I worked out that that had to have a 7. Let's just check I'm oscillating around the whisper correctly. It looks correct. I hadn't seen that this 9-1 was resolved. I haven't put an 8 in the puzzle or something by mistake. That's the sort of thing I could well have done. I can't see where I've done that. So that's tricky. The oddest thing is that it was sort of working, wasn't it? It was sort of working. It's even more odd that the digits left over to be placed here are actually the digits I would really like there to be. It wasn't... I haven't somehow misstepped with this logic that with the 4 here, have I? So what was my thinking there? This box certainly needs a 4, that box needs a 4, so the 4 has to be there. The 4 has to be on the... I don't know. I'm very confused. I think I'm going to really unwind it. I'm going to go back miles and assume I've made a Sudoku error at some stage. Now, but where? I don't know. How did I get... Okay, how did I do... Oh, I've got the 6 here, didn't I? Was that nonsense? That definitely can't be a 6. So that 6 feels correct. I don't know if I did that next. I then claimed that that made that a 4. I've got no idea why I thought that. How did I do that? Maybe that was nonsense. These are 2, 4, 7. Why did I think this was a 4? Oh, I know why. I was considering where 4 went in this column, wasn't I? And I didn't think it could go on this line. And now, is that true? I think it's true. The other thing, actually... No, and I have shaded this blue. And that does feel to me like it's got to have a different polarity to this digit. So I do think they are different. I'm just struggling to see why that is not a 4. That feels like it's a 4 to me. And then that makes those 2s, which feels sensible. It makes this a 7, which is just Sudoku. Now, okay, maybe that step's wrong. I then put, oh no, I put, oh, that could be wrong. That could be wrong, actually. Hang on. I put 7 in here. Why? I think I did Sudoku on this box. In my head, that's what I did. Why couldn't that have been 7? Ah, there. That's the error. Wow, that's vicious, isn't it? Now. Okay, so sorry about that if you've been shouting at me, but I got, you know, I got hoist by my own poor solving there. But I'm quite relieved, frankly, because I couldn't understand what I'd done wrong. Now, can we resurrect any of the logic? Is any of the logic going to be sound? Well, I don't know. Yeah, I mean this digit, these are all even, aren't they? So these are odd digits. Yeah, these are odd digits, and then they're not 5, so they're from 3, 7, 1 and 9. Now, this digit, no, what I was about to say is not true. I do have to be more careful. That's all I can say about myself. I have to be more careful. This digit is perhaps interesting, because that does have to find a home in this box, and it's not 1 or 9. No, it could be. Why? What are you talking about, you silly man? I was thinking it had to go on the whisper, but it doesn't at all. Yeah, I've got myself in a pickle. And, well, when getting oneself in a pickle, it's best to then extract oneself from pickle. Yeah, okay, this thing is all odd digits, isn't it? So the 2 in this column is here. It's on this line. Maybe that's a helpful thing to observe. Well, yes, that's the same logic. We did that before. Yeah, that's fine. This has to have with it a high digit, which can't be 9 because of the 1-9 pair. So it's still valid, I think, to claim that's a 2-7 pair. And if that's a 2-7 pair, the digit at the top is a 3. I've got a horrible feeling that's what I had before. Okay, but that's all right. That's all right. Now, these digits are now 3, 4, or 6. This is a 2-7 pair. And it's very exciting for the following reason. Maybe I do have, because the way I was solving it before, I didn't really need to use the funny old line here, did I? Which has now definitely got 8's worth of digits, plus either a 4 or a 6. So it's adding up to 12 or 14 into these squares. Now, okay, so what exactly are the well, 12 we know would be 2, 4, 6, don't we? There may be other ways of doing it, actually. 9, 1, 2 springs to mind, so maybe I've got to be more careful with that as well. Okay. I do know one of those is a 3 because I've got this 3 at the top, so I know this digit is not a 3. So this is down to 1, 7, or 9. And that's going to be very important for the following reason. I don't know. Okay, we've not put... Oh no, we don't. I still don't know how this ring works. It's infuriating. It's got to be Sudoku, doesn't it? Let's think about Sudoku. There's definitely an orange on here. What about... There must also be... No, because we don't... This is the hard thing. I don't know whether this is the black 3 or not. Yeah, I think the way I've coloured this has really... It's not helped me at all. It's definitely not helped me. I do know that 2 is over here now, don't I? That is a truth. And, oh, actually, maybe I've got to revisit the whisper after all this time. But yeah, the whisper doesn't have 8 on it. Oh, not the whisper, the RENBAN. Doesn't have 8 on it, so it can't have 9 on it. Yes, so 9 is in one of those 2 cells. But I don't think I know which. So this line here is either, if it's got 1 on it, it's 1, 2, 3, 4, 5, 6, and these would be a 7, 9 pair. Or if it's got no 1 on it, then 1 would be in one of these squares. So this digit is 1, 7, or 9. This digit is 1, 7, or 9. And that's going to be jolly important for the following reason. I haven't got a clue what that reason is. Bother. Okay. Okay, no, I haven't got it. I still haven't got it, have I? Blue is... If... Oh, I don't know. I don't know. I've got myself into a real... Oh, where's 2 in this row? That's there, apparently. Now... Okay, so 2 does have to be on this RENBAN. So 2 is in one of those cells. This digit is not 7, is it? So 7 is in one of those 2 cells in row 7, and that is not a 7. This digit is 1, 3, or 9, I think. And I know one of these is blue, but I don't know which one it is. Oh, it's infuriating. I know you're all cross with me now. I'm cross with myself. I feel like I'm not... I've been thrown by making the error. And now I don't really know where to... Oh, that's a very exciting... Jeepers, that's a loud motorbike noise. Not a maverick noise for once, but a very loud motorbike noise. Okay, is it... Maybe it's to do with... I mean, these digits have to appear in those cells. So I've got my 5, my 4. I've got... Oh, the blue digit. The blue digit needs to appear in that quadruple. Yeah, and it can't be, so it's that one. That is the blue digit. And then the other digit is this one, which is 2 or 7. But I don't know what that is. But now I've got a 1-9 pair in this row. So I can place blue. Blue is there now in this box. I don't even know how to describe it, but that's not terrible, because now this is 2, 4, 6. But I think I'm worried we're getting into the same pickle I was in earlier. They add up to 12. Now that means that there's no 6 in there. So this is 3, 4, 5. That means this is 6, which is what we had a little bit last time, I think. But this row now, I haven't had a digit in it that I should be able to put in, and that digit is 4, and that's got to go here. Okay, well that's still a little better than we were doing. And these digits are from 1, 7, 9. And I don't think I dare say much more than that about that. And, okay, now, maybe we can do better with the blue digit. Oh, goodness, the blue digit somehow. We've got to put a blue digit. Where's it going to... Where's the crux of the blue digit stuff? How do we do the blue digit? The blue digit's in one of those 2. The blue digit's in one of those 2. No, I don't know. Okay, let's go back to the drawing board again. I've got to put a 6 into... See, I don't know. I mean, there's a 6 in one of those, that's true. I don't think it matters. This could be a 6, I think. There's got to be a 6 on this funny line, the RENBAN line. And we do know that the 6 is in the top part of it, don't we? Because we know that these digits are those 4 digits. So the digits that are to be selected from here are 4 and 2 or 7, which is this digit. And that presumably does something somehow. Yeah, there we go. That is it. Where's 3 in row 4 is the question that we can now ask. And I think there must have been a way of seeing that in a lot more, with a lot more alacrity. But I don't care, because I have now seen that in this row I have only one place for 3, and it is there. So that is 3, that is 6, that's double 1. So blues are 1. I can't remember what we had with the wrong version. Hopefully it's now switched round the other way. That's 7. Oh, I don't know if it has, you know. That's 7, that's 2. So this is not 7. Well, 7 is in here. So it's not a 2 that's going in there. It's 4, 7 in this order. And these are a 2, 6, and that's a 4, and that's a 4, and that's a 3. And 9 has now gone down here. So this is no longer a 9. And hopefully we might get into better shape. Is the Sudoku working? I don't. Oh, that's a 9 now. Did we have that last time? I can't remember. Those 2 digits are the same then, because that 9 must have the same difference going right and going down. That is not a 9. But 9 is in that collection of cells, so that must go there, because, and this is 1 or 7, and it corresponds to whichever one of these is not 3. Okay, but that's fine. So I think probably what we do is, what we do is put 2 in there, and then we know that's the same difference. So that's a win for the goodies. 2 and 6 go into those cells. And now because I've got the 1 and 9 on the same difference line, I can do those. 3s, 7s, 1s, 3s. So I need a 7 up there now. And I don't know, it doesn't seem to have broken in quite the same way it did before. That's a 6 by Sudoku, so that's a 6. This is a 3. This is a 1. I definitely had a 3 in the corner last time. So that's probably good news that I had. Well, I can't remember the last time I incorrectly sang. Oh, but I might get to recorrect. Oh, no, I don't. I don't get to correct my singing, I'm afraid. That's a 6 by Sudoku. This hasn't got 4 in it. And if I've not made... That's a 1. What a puzzle. What a puzzle that is. That's very difficult. I mean, even though I made a boo-boo, I'm still going to claim that's difficult. I don't know whether that is a fair claim or not, but I can certainly blame the heat for any slowness. But it wasn't easy, was it? And it was. I tell you what, it was. It was magnificent. I'm just sort of trying to tidy up and make it look beautiful. So 2s and 6s might be the digits that were uncoloured, which is a shame for them. So we'll put that right, like that. Although I've not used yellow. Oh, I suppose I wouldn't use a colour because there's only 8 digits in the puzzle, Simon. Yes, that's going to be true. That is it right? Yes. Oh, thank goodness. Okay. Yeah, this is old. That is old. That's a lot of days. But let's just revisit how clever Marty has been to create this. It's really not easy. I don't think it is. This line does so much work with the orientation of the grid positions. It's extraordinary. And how could I have... I'd like to know how I could have got this 3-6 resolved more quickly. I suspect it was law of leftovers type logic. that I just overlooked. And I don't know. Oh, we did figure out the mistake, didn't we? We figured out the mistake was my Sudokuing this into that cell incorrectly. Frankly, we get some comments sometimes that say, "Oh, you were lucky in your solve." Believe me, there is nothing Mark and I hate more than making a lucky error. Because we never intend to. We try and do the puzzles logically all the time, and the only consequence of a lucky error is that the comments note that we were lucky. We'd much rather, I'm much happier having realised I made a slip of the mouse and finding a logical way through it than I would have been posting the video and then dealing with the comments saying Simon's a numpty. I don't mean to be a numpty, I promise. I was a bit of a numpty today. It's been a long video, but it's very hot. And it was a fantastic puzzle, Marty. And I'm sorry I butchered it a little bit. Let me know in the comments how you got on. I enjoy the comments, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.